All right, so back to the record button here. So this is class number 4. And so I thought about, since I don't have a seating chart in here, but I do have all your pictures. And now Edgar's back in the regular classroom. I can check you off this way, but I think we'll continue to do the screenshot for now. Let's see. So announcements, January, got the first week under our belt. I kept the first week up there because it had the to-do list. But look at the next 3 weeks. There, and I noticed I only graded a couple of them, but I noticed that I think I'll try to do it today. I'll try and get the rest of those looked at, sheet 4.1, and give you your 16 points, up to 16 points. But that was due last night. If you turn it in today up until midnight, you're still going to get like 15, I think, points. So, and then it starts to drop off until it gets down to 30%, 70%. Okay. So in lieu of stamps, you all will turn things in. Now, your next time you turn, 4.2 is the next one. That's what we're working on. That's the next one you're going to turn in, submit. And that one is to be submitted on Friday. That's normal. Normally it would not be a Sunday night, it'd be a Friday night thing, because you should be, I'm trying to get you to keep up and not wait to the weekend. I want you to kind of stay on top of these. And so this time, the one you have to have is 4.2. We're going to work the back together, but you still got to turn it in. The front is pretty much all homework. And we really haven't talked about it. The in-class kids want to see a key posted, but I said I can't really post it until virtual kids have turned it in. Now, I don't know whether it'll always be on Friday nights you can turn them in, or maybe it'll be a Thursday night. Because remember, it slows me down because I cannot post a key until you turn it in. But I already said Friday. Okay, so next time it might be Thursday night. Yeah.
I don't know if this is the same for everyone else, but the only place I can find to turn in the 4.1 is on the calendar, and I don't usually look at the calendar. I just go to the modules.
The calendar it's the home page of Canvas. So if you go to Canvas at all, isn't that the first page you see?
No, I mean the actual Canvas calendar, and like in the modules on your class, there isn't an assignment specifically to turn in the thing. You have to go to the Canvas calendar and then click on the assignment from there.
I'm confused because it has to be an assignment in my assignments, or it wouldn't have been in my grade book. It shows up in my grade book, so it has to be under assignments. Are you looking at semester 2?
I can't see the assignments either. I can't see any assignments that you have assigned for semester 2.
Well, I've only assigned one. Well, I assigned more than that. I mean, let me look right now.
Yeah, like when we go to modules, it only shows the wrap-up videos and the PDFs for the packet.
Okay, thank you. See, if I go to assignments, you don't see assignments though. If I go to assignments, there they are. But if I go to modules, let me check. Maybe assignments aren't in modules. There's a wrap-up videos, there's PDFs. Okay, I see what you're saying. All right, so
last semester we had an assignments tab on the thing, but now I don't even see an assignments tab.
I'm going to add that assignments. It's you'd have to go to assignments. But I agree with you. So let me give you a couple of Zoom points for that. Thank you. And I'm going to fix that this afternoon. So it'll show up under your assignments. Yeah. Okay. Do you see assignments in your like in your menu?
1 second.
I'll move, but I will move.
I did not. I looked for it, and it's not in my menu.
Yeah, it's not in mine either.
In your menu. Okay. Yeah, well, Canvas. All right.
So right now, the only way to access it would be to go all the way to like the left side of the Canvas page and click on calendar there. And then you can see the assignment for today, but you can't actually find it on your Canvas page.
Well, that's not, you shouldn't have to do that. So let me remind myself, I got to go back and think, how do I add that? I'll add that. It's in there. Oh, plus module. Here we go. Plus module, module name. Oh, well, I don't want to waste our time right now doing that, but I will, I'll fix that this afternoon. If you see, if it's not fixed this evening, if you still can't find it, then text me or something, okay? But I'll make a note to fix, write a note right here. Okay, fix. Thank you for that. Fix assignments. I'll know what that means. All right, so thank you for pointing that out. And I apologize. Okay. Anyway, there it is. And then the one from Friday, I'll put that in there as well. And we'll get that straightened out. Okay. So you don't lose a point, but I won't count it off if you turn it today. Okay. If you couldn't find where to find it, because it wasn't in the modules like it's supposed to be. All right. I don't see a quick way just to drag and drop it, but I'll look at it. Okay, so tonight we'll have, there'll be an assignment, and it's to finish up 4.2. I don't know why I pushed it all the way back to Friday to make that due. I don't know why it wasn't due. It should be due before Friday, because the thing is, look, don't get mad at me, but I'm going to move this because I can't post a key to 4.2 until you all have turned it in. So I'm going to move that guy to Wednesday, just so I can post the key on Thursday. So I apologize to that, but that was a problem this morning because kids are going, I need to see if I'm doing this right, and I don't know if I'm doing it right. Okay, you can always go to Facebook and ask. The calendar is not on Facebook, but I might start putting the calendar on there. The thing is, I change that calendar 3 or 4 times a day. Now I got to change it in both places. Whatever. All right. So tomorrow we meet table 4. I try and meet. Maybe what we'll do here, instead of meet table 4, I'll try and, like, once a week, talk to one of you so that everybody's listening, and ask one of you some questions, personal questions that are softball questions that you can always pass. But it's a way that we can get to know each other in class, and maybe it's to be a way that we get to know each other on the Canvas. On the Zoom. Okay, tomorrow afternoon, it says it'll be posted by 6 p.m. It'll probably be posted more like 3 p.m. Tomorrow afternoon, there'll be your first set. This is on your calendar. There'll be your first set of practice problems. So second semester, the first part of the packet is, there's not going to be a take-home test. It's only going to be practice problems. And then there'll be 18 to 20 practice problems. You'll get 6 tomorrow. And you could just blow them off. But because they're not really, it's homework, and you write on a piece of paper, you write in your notebook, and you get credit for them when I grade your notes. In fact, most of your notes will probably be, tell you the truth, will probably be these practice problems. And they're a little bit more difficult than your typical classroom, plug and chug problem. Most of them. There's usually something a little bit interesting about the problem. Okay, so those tomorrow will start to be posted, and you don't have to do them. But if you don't do them, then when it comes time for the test on the 28th, it's going to be the hardest test you've ever taken in your life, because you have no preparation for it. So going in and taking a test 4A or 5A or 6A cold is going to be devastating for you. So yeah, you really do need to work on these. And I'm not going to leave you hanging. I mean, the whole point is, this is on Unit 3, I think, of the Facebook group. And you can ask questions of each other. You can comment. We can talk. We can work through each problem. And it won't be a piece of paper. It's not something you don't get this off my porch. There's not a PDF of it. The problems will be posted on Facebook group. I know this does not make Miranda very happy. We'll have to figure something out, Miranda. And so that's where you're going to get all that information. And then we'll work our through the problems. I'm trying to avoid having a paper back and forth. I don't want to put these on the canvas because I'm going to run out of room even faster than I did last semester. So there's an issue with that space. And plus in Canvas, you can post them, but you can't do anything with them. You can't do back and forth. You can't talk about them. I want to include in the comments, I'm going to include like not just help and eventually a key, but also help videos about how to do this problem. So that starts tomorrow afternoon, okay? Thursday in class, we'll be on the air rocket. We'll be launching the air rockets on the West Lawn. We'll do a video for you. Let's see. And then the next set of those practice problems come. Oh, one good thing about this is if you have a sharp eye, you'll notice that the Canvas quiz that was supposed to be given tomorrow night, I have taken it out. I felt like I was giving you homework. I'm giving you practice problems. There's a test coming up, and now I throw a quiz at you. I mean, it's just almost too much, you know, for one class. And so I thought maybe I need to back off a little bit. So I backed off the Canvas quiz. I left one up for next Wednesday, and I'll see how it's going. I may or may not end up going with the Canvas quiz thing. I thought it might be a nice way to find out how you're doing. Anyway, so the next set of practice problems comes out on Tuesday next week, and then the last set comes out on Sunday the 24th, and then we will have an hour and a half Zoom dedicated just to those practice problems, but that's on the 26th. And right now scheduled for the 27th is a flex day, which is not going to make much difference to you, but that's when in-class kids have the option to come or not come. You have the option to come to school and get help. They can come, they probably will because the test is the next day, but it's a weird schedule. We're still working on it. It probably won't affect you a whole lot, except may change the time that we have our session because science occurs at a different time on flex days. I don't know. They're trying to find a way to accommodate, mostly for you guys, to tell you the truth. The flex day is for the virtual kids' benefit. And the other good news is that, so one good news was that no Canvas quiz this week. The other good news is everyone gets a temporary cushion for second semester. It's supposed to be 100 out of 100, but I got tired of hitting the 1, then going over the other side of the screen, 0, 0, 1, 0, 0. So I just went 1, 1, 1. So it's 111 out of 111. Everyone gets that up until, it'll be there to keep your grade cushioned up until about mid-February or late February. And then by that time, everything else is graded from Pkt4 and your notes and all the stuff is graded. So now you already should have cushion. And so then the fake cushion goes away. So that should at least keep mom and dad or whoever at home off your back through the month of January. But, you know, don't take advantage. Keep working. Okay. Now, this is the point in the classroom where I go around and check. So these, just so you're honest here about it, you need to keep up. You should have done number 3, 4, and 5 now, but completed the front of 4, 2. I'll post that key. Now it looks like Wednesday night, well, Thursday, because Wednesday now you got to submit it. Wednesday, I'll change that assignment. I'll add that assignment. So it's Wednesday that's due. We're going to finish the back, most of the back today. Okay. Dinner joke Monday. All right. This one, there's a side 7 now to the sheets, to the help, to the, you will not get this though. Well, you're not supposed to use it. You have PDFs, but in class, they're not going to get side 7. So to be honest, you guys should just look at side 1 through 6 because the test is testing you over some of this stuff. Now, it's good to have this though in your notebook, print it off, put it in your notebook, maybe have a little PDF section if you just want to stay all electronic. But so the first one is those 7 situations we talked about with the window shades last week. And then then there's something about inertia. We talked about inertia being, you know, like your resistance to change. And then there's Newton's first law of motion, more of a modern version of it. And then we said, what if we were to put it on a t-shirt? And I said, objects resist acceleration. That's the one we had last year. But this year, I kind of like maybe changing the word objects to mass. Mass resists acceleration. That's the same thing, but more physicsy. Anything with mass resists acceleration. Photons, light has no mass, so light does not exist. Light does not resist acceleration. In other words, light can't speed up or slow down. Okay, hold on, be careful, be careful. I gotta be careful on this. Light through a vacuum can't speed up or slow down. You can only go at one speed. Light does slow down through different mediums, and that's why you have bending of light. That's why you have refraction and even reflection, because light does slow down through different mediums. But through a vacuum, light cannot slow down or speed up, cannot accelerate. All right, now fundamental forces. We talked about these 4 forces on Friday. I'm not going to go over all through it again. In class today, they asked questions about these particles over here. So I'll repeat a little bit of that. The gluons, what are these? Are the carrier force carriers, they call them. And for strong nuclear force, it is gluons, apt name. Gluons have no mass. They're called pi nucleons, and they are between quarks. They keep they're the force that keeps the positive proton and the positive proton from splitting apart spontaneously. If you mess with the gluons, you have a nuclear explosion. So Nagasaki, Hiroshima was basically turning a tiny bit of mass, a matter of ounces, grams, into energy, pure energy. And that happens with the explosion of a nuclear bomb. If I took the mass of this pin, a stylus, and I converted it directly to energy and messed with those gluons and tapped into that strong nuclear force, this would level all of Norman. All of Norman, a good chunk of Noble. It would set half or more on fire. The energy, this frozen energy that's in this pin, tied up in those gluons, the gluons are the carriers, but tied up in those, what holds the quarks and what holds the protons together and neutrons. Electromagnetic is photons, a photon. Basically, okay, we talked about this. So if I have an electron coming along, an electron comes along here, and another electron comes along, then one electron will shoot a photon, actually shoot a photon, like a photon torpedo. It'll shoot a photon, which is energy, which is shown as a wave. These are called Feynman diagrams, named after Richard Feynman. He came up with these in the 1950s, early 60s, and it finally allowed people to start to understand quantum physics, because before that, it was all matrices and all mathematical equations, and nobody could visualize it. When this happens, this photon, because it shot out, this electron, because it shoots out, think of it that way, a photon, it recoils and it comes back this way. And this electron, because it caught that photon, rises in energy, it gains a level of energy, a quantum level, and then shoots out the other way. So this is the reason why the electrons repel each other, is that they are shooting photons at each other. This photon war going on. So photons are the force carriers in electromagnetics, okay? And we'll get into Feynman diagrams, maybe a little bit. We'll come into it off and on. There's a part in the class where they kind of naturally, we need to talk about them. But yeah, if you want to look up something cool, Google Feynman diagrams, and it lets you visualize. He was the master teacher. It lets you visualize a lot of what's happening in the subatomic level, not just between the electrons, but between quarks. Why neutrons, spontaneously turn into protons sometimes with beta decay. All that didn't make sense to me until I started looking at the diagrams. Then it's like, oh, that's cool. I'm a visual guy. Now, weak nuclear, those are Z and W bosons that are the force carriers. They have a little bit of mass, not much, a little bit of mass. And then gravity. Now, gravity, if you want the Nobel Prize, which comes with about $1 million you get to play with, but if you want the Nobel Prize, why don't you go ahead and find out gravitons? Why don't you discover the graviton? That is what we think the force, if you consider gravity a force, that's what we think the force carrier is. We're calling it that. The force carrier is that causes two things with mass, say my iPhone and this stapler. It causes two things with mass to want to come together. Those are gluons. And so, not gluons, those are gravitons. And gravitons are what keeps the moon from leaving its orbit, what keeps the Earth going around the sun. So that they work, the more massive the object, the more gravitons there are that are kind of acting as a beam to hold things together, if you want to think of it that way. But nobody's discovered them. And the main reason why nobody's discovered them is they're so daggone weak. They're weak. They don't show up on we don't have instruments that are, think about it. We just don't have instruments that are accurate enough to detect them. Okay. Like, for instance, okay, last thing I'll say on that. Nobody knew what the heck was making everyone itch all the time this is Robert Hooke. So we're talking late 1600s until Robert Hooke started. He didn't really, he ended up using the first one to really scientist to use the microscope. And in that microscope, he wrote a book called Micrographia, which was the bestseller because he was a very good artist. Robert Hooke did a lot of things. We'll study Hooke's law later on. But he drew for the first time what a head louse looks like, what head lice and what fleas look like. No one knew what the heck because we couldn't see them. So when you saw it, then you start to work, oh, well, that's a louse, and I see how it hangs on to the hair, and that's why we can't get rid of it. So that's what needs to happen. We need to find some kind of a microscope that'll go down. I mean, it's not a visual microscope. Something, we have electron microscopes, but that's still not small enough to go down to the level of a graviton. Now you're on the level of strings. And so I don't know if we'll ever get that fine of tuning to actually detect a gluon. Okay. No, why would I say gluon? A graviton. Hello, a graviton. They're just too small and too weak. We assume they're small. Maybe they're big, but they're weak. We have detected gravity waves, but that's not the same thing. We didn't think we'd find gravity waves either until about 3 or 4 years ago. And then those two black holes collided 1 billion or so years ago. We finally got the wave from it. And that took the place down in Washington State and down in Louisiana. And it took that huge array to find that. Okay, so we just don't have an instrument yet to find the gravitons. So this weekend I thought, well, I can run numbers at my kids, but I needed more of a visual. So here's a visual showing strong nuclear force, electromagnetic, and weak nuclear force lined up. This is to scale. So strong nuclear is 10 to the 37th. Actually, now I'm seeing it's higher, but back when I was teaching this 20 years ago, it was 10 to the 37th. Now they're saying 10 to the 39th. But anyway, huge amount bigger than gravity. So there's strong nuclear force. Electromagnetic is the one in blue. That's the one that you'll study when you take electromagnetics, which is either your third year of high school or your second semester of college. And it's dictated by what's called Maxwell's equations. I have a ceiling tile, but I pointed this out in class. But anyway, you can look up Maxwell's equations. And maybe if I remember, I'll tell you what, I'll write a note. Maxwell's equations. I'll add Maxwell's equations to the screenshots. Maxwell's equations is what Einstein used. Einstein, bowed down to Maxwell. He had a few heroes. Ernst Mach was one. Spinozzi was one. And James Clerk Maxwell, though, was his number one hero. Anyway, so Maxwell's equations puts together all these equations. But the thing is, 4 equations, and you can use those to explain all electromagnetics. Anyway, so the problem is that you have operators in there. You have dot products and cross products, but you have operators that require Calc 3, Calc 2, Calc 3 in college. So Calc BC, the harder one, times 3 years of Calc BC. And then you can start to understand, well, maybe second year, but you can start to understand the advanced calculus. In other words, you start to understand Maxwell's equations. There's a reason why you have to have calculus. Okay, then electromagnetics, that's the one with photons being the force carrier. That's about 100 times weaker. So you see it's still a pretty good bar. And then you got weak nuclear. That's what causes the sun to shine. And that involves beta decay, some other things. But that's about 1,000 times weaker than electromagnetics, but still in the ball game, right? And then here at the very end, you finally have gravity coming up, not just 4th place, but a sad, desperate 4th place. If this were a marathon, strong nuclear crosses the finish line. An hour later, strong electromagnetics crosses the finish line. About 3 or 4 hours later, here comes weak nuclear forces. And then about 2 weeks later, gravity crawls over the line. Now I was being generous to gravity. It's about 1/10 that size. So so Einstein, seeing this, started thinking, gravity, I don't think gravity's really, it doesn't fit. Gravity's not even a force. And then he started thinking about elevators and about relativity. And he said, he came to the conclusion in his general law of relativity that gravity is not a force. Now, it's convenient for us in classical physics, which I teach, which you are in, that is convenient for us to consider gravity as being a force. I mean, this iPhone falls. We make the assumption that something is pulling it down to Earth, this field force. And that works for us. You can write a lot of equations that way. So we do it. But when you get to modern physics, that'll be your junior in college probably. If you take the 3rd semester of physics, they will start to teach you Einstein's way. Okay, but that's not the nature of this course. We're not modern physics. But I don't hate to lie to you. I'm not really lying to you. It works. It's a good model. It's good grief. That's what most astronomy is based on, is the idea of, gravity being a force, right? There's some kind of force that holds the moon in its orbit, that holds the Earth in its orbit, right? So it works. The other thing I wanted to show you on this, remember I told you earlier that you'll have help videos on, sometimes you'll have a silent help video or a help video on these practice problems I'm going to give you tomorrow. Here's one of the practice problems. And this was actually on a take-home test. It looks like, I didn't say when, but it was, oh, there it is. It was last fall. This is a take-home test. So this is a problem you'll have tomorrow. But the point is, there's a silent help video. So if you just hit the play button, and I'll put the links to this in the Facebook group. You can just go to you can also just go to the YouTube channel, and you'll find it there under free fall. But I'll put the links in there. Okay. So you'll have, but not the day one. I want you to try it first. Then you'll start to see links after you've given it a day or two of effort. Okay, so now on to today's physics. Any questions about all that stuff before we get on to today's topic with 17 minutes to go? Okay. So the front of 4.2 is all homework, and go to Facebook, ask questions. There's comments there, ask questions if you got them. And now the back. Please tell me that we did 6. Give me a thumbs up. Hit the thumbs up icon. We did 6? Yes. So Sophia's saying yes. So for some reason, I don't see work done on it on our sheet, but that's okay. That's all the wrong one, I guess. Now, the only thing we got left to do is 7. So thank you, Rose. Okay. And Takaki. Number 7, I sent them to the board on 7A, B, C. And then we worked D and started to work E, and then we ran out of time. And so I assigned the rest of this for homework. Okay. So let's go ahead. I'll let you all, might as well, I'm going to play with this. Breakout rooms. Let me just try this here, because this would be a board problem. So I'm going to put 3 breakout rooms. I'm going to assign automatically. I've never tried this before. There'll be about 3 or 4 participants per room. Let me create. Okay. It says, Anthony, you can't see what I'm seeing. Evan's going to get moved to room 1. So room 1 will be Anthony, Brandon, Evan, Sophia. Room 2 is Bennett, Brady, Michael, Rose. Room 3 is Eric, Miranda, and Takaki. Okay. Now I'm going to open all rooms. Okay. So you all, I think, have been moved to your rooms. Maybe something's happening on my screen. Okay. So it looks like people are now in their rooms. Ooh. Whoa. That's weird. Okay. And I'm going to broadcast a message to everybody. Let me broadcast you a message. Can you read? I don't know if you can still hear me. Can you read this? Can you read this? Broadcast. And I don't know how you say yes or no. And then do this. Can you hear me? Broadcast. Okay. Now I cannot. Oh, so let me go to your room. Room 1. No. Close all rooms. What if I want to visit a room? Hold on. Join. Join room 1, yes. Room 1. Hey guys.
Hello.
Oh, so you guys are talking to each other. You're talking to each other. Oh, okay, cool.
Yeah, and you can like pop in each room and
yeah. So I popped into your room. Now I'm going to go pop into another room.
All right.
Okay,
we can see those.
While you all are
couldn't
talking to each other, you guys should be talking about this problem 7. Okay.
And we're
How-
doing A through D or A through C?
Which ones do we do, Mr. Askey?
7, ABC.
Okay.
See you guys. Oh, leave. See you guys.
See ya.
So I think it would just be 0 meters a second minus 30 meters a second over negative 9.81. And that's time. That's A.
Yeah, and then I got the correct answer.
So
Yeah.
sorry to jump in here, but you guys, I'm joining your room for a second. So you guys are working on 7ABC, right?
Right.
Okay, good. I'll leave you alone.
All right.
Leave this break. Okay. Hi guys. You all are being silent. Now the other two groups are working on 7A, B, and C. And I'm joining your room. We're going to go with rooms for another couple of minutes, and then we're going to come back together, okay?
Okay.
All right. So I'll see you guys in a minute. Okay, so the recording is recording me or whether it's recording the rooms, but I'm going to close all rooms now. Oh, okay. All breakout rooms will close in 50 seconds. Okay, 49, 48. Interesting.
They can also just return back.
Oh, they can return back. Okay, you have the button to hit that says return back to the main room. Oh, so it gives you like a minute to finish your conversation, and then you can come back. So it's like going to the board, and then people kind of mosey back to their chairs. So it is sort of like going to the board. I kind of like it. So, right. So with that one, I put you all together randomly. I kind of like that, probably just randomly. Otherwise, I got to figure out who goes with who, and it doesn't matter. We are okay. So we're all back together now. Well, that was interesting, and I'm unmuted. Yeah, it's weird. It mutes me, and then so that's really cool. I can broadcast everybody, and so I think probably 4 rooms is the most I'd ever do. But we're looking to do this when we do our ACT review, looking to put kids in the rooms. But we're just sort of I'm playing with it. But I kind of like it. So you got a chance, and I saw that a couple of groups were talking to each other. One group was all staying silent, but the idea next time we do it, the breakout room, I'll give you an assignment to work on with just a small group, and then you'll know whether I'm there or not. I'll kind of walk between groups. Okay, so sharing, I think we're still sharing a screen. Do you still see my screen?
No.
Okay, that's weird. Stop sharing the screen. All right. When you go to breakout rooms, the sharing screen ends. All right. That's good to know. Let me share it. We're almost done here. We've got about 6 minutes, but you all worked on this. I heard you working on it some. It's not a weird problem until you get to D, because we've worked. If you go back and look at the situations, this is this situation, right? Well, you tell me. Look at these situations. Which one is this one? Throwing a ball in the air and then catching it where you let it go at.
Would it just be number 6?
Yes, and so we blow that up. So you already know that your graph is going to look like this. So there's some advantages here. It speeds you up. On this problem, this was 30 meters per second, right? V naught. Well, then what is this right here? What's V final?
Negative
Negative
30 meters a second.
meters per second. So that just it makes that part, whatever that C is, whatever it is, easy, because you know symmetry. Now so for the other one of those, I don't know if it was B or not, but it said, what is your delta Y? So you're trying to find that height. What is your tau, your total time? Of course, this will be half tau. So half tau will get you to the top. Also, we know at the apex, we know that V at the apex is equal to 0. So you can use all this information to pretty quickly solve this problem, A, B, and C. D gets a little weirder though. It says, how long will it rise? Well, I don't know if you were doing this, but if you just go ahead and use that V apex, which is sort of the launch equation, which we'll talk about tomorrow, because V final at the apex, if I'm saying V final is, I better not say that, V apex, which we know is 0, equals V naught minus GT, or G half tau, that's half tau. As long as it comes up and the lands back in your hands, that is half tau. So how long will it rise? We simply have G half tau then, half tau is going to be negative V naught over negative G. G, of course, is positive, so you'd plug in your 30 there, 30 meters per second. You'd plug in your 9.8, I'm on buffer here. You'd plug in your 9.81 for G, and then whatever you get there, what's a little over 3, 3.1 or something. Okay. Then how high will it rise? Well, I guess you're trying to find that delta Y, so you could use third blue, right? Because V apex is 0 equals V launch, which is V naught Y squared minus 2G delta Y. So you know everything. You just got to solve for delta Y. And then how long after it leaves the hand will it return back to the starting point? Well, now you're trying to find tau, but you already found half tau in A, so just double it, and now you have tau. twice whatever a is. But in the couple minutes we have, the question that I left them with was, when will its speed equal 16 meters a second? And one of the keys is speed. When I had it, because the reason why it caused them problems is I had a group do it, and they got the answer that they got for that one. They got 1.43 seconds, and they plugged it into one of the equations. I guess it could be the first or the second, probably. First is probably the easiest one, right? Just plug in, just say 16 meters per second equals 30 meters per second. That's V final equals V naught minus G 9.81 meters per second squared times T. Not, this isn't tau now, it's just some random time. And from there, when you solve for T, you get 1.43 seconds, and everybody's happy. But you'd only get half credit on that on a test, because there's 2 times. Notice the answer. There are 2 times when the speed is 16 meters a second, and someone explain that one to me. Why are there 2 times when the speed is 16 meters a second?
Because it'll also read. Oh, I'll let Eric.
Okay, because like it's both going up and falling down.
Right. Exactly. So up and down. So back on that, we have, it'll be 16 meters a second here on the way. Let's say 1.6, whatever that was. So it's 16 meters a second here, whenever that time is. And then it's also negative 16 meters a second there, because it goes up and it comes back down. It hits it here, it hits it here, and it hits it here. At both those 2 places, but one's on the way, because I said speed, and speed is the absolute value of velocity. Okay. Well, your homework then is to finish this, to do E, F, G, and H, and then draw. It says sketch, but you can get a pretty good drawing. I'll give you a nice graph there. Draw it out. Okay, and there's a couple of practice problems kind of like this. So, okay, that's it. We're at 2 o'clock. Let me stop the sharing and stop sharing. Okay, so any questions before I'm going to end this? Let's see,
I'm still confused on how you get the second, like the 4.6
okay,
seconds
if you'll plug in
coming
negative
back
16,
down.
yeah, Rose, plug in negative 16 meters per second for velocity, and then solve it algebraically, and you'll find that your T must be whatever it is, 4 point, whatever that thing is. Okay.
Oh, okay. Thank you.
Also, since it's the same going up as it is going down for this one, you can just subtract the first time from tau.
Yes. Yes. So Bennett, there's another Zoom point for Bennett, because he's saying, let's just use the law of symmetry. And the faster way is to go to the graph and go, okay, I know what tau is. So I know that 1.6 seconds into it, it was at that. Therefore, 1.6 seconds before it ends, it's also at that point because of symmetry. So good job. That's true. Okay, everybody. Great way to end it. We'll see you all tomorrow. Have a good Monday. Bye.